Okay, good afternoon. My name is Jiyoung Choi, CEO at VALUENEX, and I'd like to talk about quantum computing landscape. So for those who doesn't know about VALUENEX, actually VALUENEX is a predictive big data analytics company specialized in data visualization, and we have our proprietary visualization algorithms, and we help clients to find out their data-driven strategy and decision-making. And actually, we started in Japan, so we have a lot of Japanese customers. So our mission is creating knowledge and insight with the data, and we provide value to everyone who seeks knowledge and insight with the data visualization and analytics. If you think about data, information, it's not enough. Once you visualize, you can really get a lot of interesting insights, where it's emerging, where it's white space, where's a lot of high density areas, and so on, and really think about your strategy. So, quantum computing landscape, I want to talk about two landscapes. First is network of key players, and the second, technology. So first, network of key players. So this conference, why are we here? After pandemic, everything can be accessed, everything can be accessed through online, right? Why are we here? So I think it's all about network. You come here to meet people, really build meaningful relationship, right? Great. But the problem is, if you just randomly walk, you will be all over the places. So, I think, here maybe 1,000 people came, but even if you meet 25,000 in your life, there can be a lot of white space. So meaning there are a lot of white space people that you will never encounter in your life. So how can we do more efficient networking? So to build stronger network of people in quantum computing, I'd like to ask 3 questions. First, how the landscape of key players in quantum computing look like? And where am I? Also, how can I navigate myself in the network of key players? So to answer these questions, I gathered data from Crunchbase, which is a startup database, using quantum computing as a keywords. So gathered 332 companies, mainly startups, using quantum computing in their business description, saying that they're doing something with quantum computing. And within those 300 companies, there are thousands of companies, founders, and investors. So for example, QCware, the founder, Matt Johnson and Randy Coral, is very connected to their investors. For example, Artemis Accelerator. And actually, the same investor invests in Rigetti Computing. So QCware's founder is connected to the investor and maybe reach out to Rigetti easily, right? So that's the concept. But there are a lot of data, right? So to make it efficient, I visualize it. So this is the visualization of 1,000 companies, founders, investors, data. So if you look at this map, you will see a lot of dots, blue dots, that we call cluster, that represent either companies, founders, or investors. And in Silicon Valley, a lot of people talk about inner circle. You can see the clear inner circle in the center, who are very highly connected. So I zoom in to really show you the details of highly connected key players in quantum computing. And I could identify around 11 subgroups of investors and founders and startups. And I highlighted 12 key investors in this quantum computing network. And I also investigated their nationality, where they're coming from. And I tagged all those key investors, headquarters, and as you can see, there are mainly 2 groups. So upper side and downside. So upper side, mainly investors are from US, Canada, and also some Singapore and UK. And downside, the bottom side, UK, EU investors. And when I look at this radar, the map, the network map, I could identify maybe key investors who can connect upper side and bottom side, the US and EU, which is Creative Destruction Lab from Canada and Innovate UK from UK because of the distance in between. Also, I saw in QTEL, investor is here on the day one, but in QTEL and Vioma Ventures from Finland are the farthest. They're kind of far from each other. So, how to strategize networking, right? I recommend them to, pass through this line to get to Vioma Ventures. In 7 steps, just 7 steps, you can reach out to this Vioma Ventures in Finland, and along the way, you will create meaningful relationship along the way with the key players in their portfolio companies. Also, I want to show a detailed map in the core groups, and I want to focus on this center of this network map near Y Combinator. So Y Combinator invested in Rigetti Computing, and Rigetti Computing is also funded by Alchemist Accelerator, and also they invested in QCware. So my suggestion to QCware and Rigetti is maybe you should just talk to each other to expand the network through their investors and their portfolio companies. Also, I want to talk about EU side as well, mainly from this European Innovation Council, because they're the center of European community. So European community. And I also note Quantum Delta is here. And I can see this network from Quantum Delta to Qblocks through the common connection unique. And there's a multiverse computing. I know CEO of multiverse computing is here in this conference. And I suggested that maybe they should talk with European Innovation Council to really build this community based on this network. So key takeaway of this quantum computing landscape of key players network. First, it seems like there are 2 main groups in this investment relationship. And one is US, Canada, and Singapore and UK, the upper side. And the bottom side is mainly with UK and EU investors and their portfolio startups. And to really connect this US side and EU side, I suggested that maybe Creative Destruction Lab and Innovate UK might be the good bridge to connect those 2 groups. Also, if you know where you are, maybe you can really be more efficient in your networking so that you can build stronger community and groups. And also you can strategize how to get to the people that you want to meet. So that was the network. I want to talk about technology. So to understand technology, I want to ask these 3 questions. First, what is the trend and where is the opportunity in quantum computing? And the second, what is the focus area of the key players? And last, how the competition in quantum computing look like using patent data. I know that people talk about IP, patent, very important, but there are so many, right? I identified around 3,000 patent application data from USPTO, US Patent Office, and it's increasing rapidly. But how can you go over 3,000 of quantum computing patent documents? It takes a lot of time. So I visualize it. So this is the visualization of 3,300 US patent application documents. And similar to the previous network map, the blue dot represents the documents, in this case, the patent documents. And the distance will represent the similarities of those patent documents. So it's very intuitive. It's just looking at the map. So if it's close, very similar. If it's far, not too similar. And the contour line and the heat map represent the density of those documents. So you can really see, okay, where is the high density area, high focus area, and where is the low density, low focus area. So that's the basic. Also, I got a lot of questions about what's the meaning of axis. Actually, it's just like looking at the map. There's no specific meaning of the axis. It's just the relative distance of each other. So actually, that's the optimization problem that we are solving. So that's why we are interested in quantum computing. So I want to explain these specific technology areas. So right side is mainly the hardware. So we start from superconducting qubits and the components of those. So quantum chips, superconductor, electrodes, Josephson junction, and quantum processor cell and resonator. So those are the quantum superconducting qubit hardware-related patent areas. And there's topological qubits on the right bottom, and quantum dots, ion trap, and neutral atoms, and quantum annealing. So those are the hardware-related patent areas. And there are other supporting technologies like calibration, error correction, stabilizer, and tensor network, and hybrid quantum classic computer, generation and compilation of quantum circuits, and application areas, machine learning, simulation in finance, simulation in chemistry, optimization, quantum computation network, distributed quantum computing system, quantum computing service with local edge devices. So those are the application layers. And this is the line, the black line, shows the trend of this movement, this data set. So it's like eye of hurricane. This black line will tell you where this industry started and where it's moving towards. So basically, it seems like this quantum computing industry, represented by patent data, is moving from bottom right, which is the hardware-related area, and upper left, which is the software and application area. So to simplify this, it's like this. So the trend is showing that the quantum computing industry is moving from hardware to the software and application area. But there is a chance in between hardware and software. It seems like there's a big gap in between. So it's not really connected yet. Also, this is a patent landscape. So there's some still opportunity to really connect those two and really position yourselves in between to dominate this market, because that's important. And I can also filter based on the players, of course, IBM. They do a lot. And when I look at this radar, I can see the good balance between hardware and software, especially hardware, of course, superconductor, and software, the supporting technologies. They focus a lot on generation and compilation of quantum circuits. And when I look at their top inventors, Gambetta J, he also focused a lot on this generation and compilation of quantum circuit. So it seems like it's important for IBM. And when I look at D-Wave, of course, D-Wave is doing quantum annealing, but they also work a lot on quantum processor cell and machine learning. And Microsoft, interesting, because Microsoft, of course, is working a lot on topological qubits. But the position is important. It seems like topological qubits is on the far right side, but it's not connected to the left side, which is the software and application area. So my guess is it might be a little bit difficult to connect those dots. It might require some time to really bridge the gap in between the hardware and software and application area for Microsoft. And Google. So Google is working a lot on calibration pattern and machine learning. No wonder. Also Rigetti, they also work on this quantum processor cell and simulation in chemistry. So these 5 players, I combined all those 5 to see where is the highly competitive area. So more than 3 players are working on it. So I identified 3 main areas that is very highly competitive. So 1, error correction, and 2nd, hybrid quantum classical computer, and 3rd, machine learning, especially deep learning and neural network. So those are the areas that they're fighting each other to really dominate the market and make a breakthrough. So, summary. I show you this quantum computing landscape in technology. So what's the trend? So trend, based on the data, the patent data, seems like that the trend is moving from quantum computing hardware to software and further the application areas. But there's still gap, the white space in between hardware and software. So there might be some opportunities for the players. Also, the focus areas for those 5 players are slightly different. So IBM, of course, they're doing superconductor qubits, but other than that, they focus on generation and compilation of quantum circuits and D-Wave, and also Rigetti, they're working a lot on quantum processor cell, and Microsoft stabilizer, and Google calibration. So those are their main focus. Also, most competitive areas are error correction and hybrid quantum classical computer and machine learning. So that was the quantum computing landscape of network and network of key players and technology. Thank you so much. Do you have time for the question?
Thank you, Jiyoung. Yeah, we have time for one question, if there's any question in the audience.
Any questions?
Just quickly, on all those graphics, can you give us a sense of what the X-Y axis is as well?
Yes. So there is no specific meaning of X or Y axis because we really optimally position the documents or the people. So there's no meaning. It's really looking at the star. There's no meaning of axis. The importance is the distance, because distance will represent the relative similarities, or the network map distance will represent their relationship, how close they are related, how much they work together.